Awesome. So, as you can see, this is Carl. What are you talking to us about today?
I'm going to be telling you about so I want to talk to you about overly defensive programming. This is a talk that I wrote as part of code that I was actually seeing. So if you see some code examples, think, who would do this? People I work with do this. This is real code. This is real. These are real patterns that I've seen. So my name is Carl Vitullo. I am on Twitter and I'm on Discord. I'm the lead moderator of Reactiflux, which is the largest online community of React developers. It's pretty great. Definitely check it out. Join.reactiflux.com. I'm a senior front-end engineer at InRhythm, which is a software consultancy. Yeah, there's a lot of people in the audience from there. We work with Fortune 50 financial companies in the New York area. We are always hiring. So if you're looking for a job, definitely come and talk to me at the end. And right now I'm working at American Express writing code. This is some of the clients that InRhythm works with. We are a modern technology consultancy firm. Lots of stuff. Yeah. So when you're writing code, you should be asking yourself a question. Are you handling errors, or are you just being safe? The difference really being a level of deliberation and intent. Have you planned for the error cases? Have you thought through what errors might happen? Or are you just sort of saying, I'm just going to suppress this. Like, this threw an exception, so I'm gonna make sure it doesn't throw another exception again. So I hate this line of code. Why do I hate this? What's the problem with this? No error handling. Well, sure. So there's no dot catch. There's no second argument to that then. Other than that, different one.
Why would data document ever be undefined?
Why would data.document ever be undefined? In what circumstance? So first of all, the only time we're going to get no document in our response is if there's an error from the backend. The backend screwed up without throwing an error code. Second of all, if we're missing document, and why would an empty object be an appropriate substitute? It's not going to work. So what about this? Why don't I like this? I've seen this a lot. And actually, so this is a more verbose form of the pattern of like lodash.get. It's basically the same thing. Really, you're inspecting an object, you're getting a series of keys, and if it doesn't exist, you want to get undefined. That works, but if you get undefined, you're just going to get an empty string. You're not going to, if your backend screws up, if somehow you end up with an empty object instead of document, you're just going to get an empty page. And so then if that happens, like your error handling isn't going to catch it, your logs aren't going to catch it, and it's just going to silently fail until somebody looks at the page and goes, whoa, this is wrong. So no automated tool is going to catch it if you do this. So if you don't have your data, can you actually continue? Or are you just creating a different error that's going to pop up later? You wouldn't drive a log. So why would you pass an empty object? If you don't have what you need to actually continue, just don't. A big part of this is understanding what's being guaranteed. In your backend, the guarantee for that example before is that it's going to provide a document object as a top-level key on the response. That's the contract you have with your backend. So for external data coming from your backend, you need to figure out a shared contract between you and whoever writes your backend code. You have to know who to yell at, but don't actually yell at them. Just be respectful. And bad deploys happen sometimes, especially in staging. It's going to happen. Really, the best thing in that case is that you find out fast. Because if you refresh your page and you get nothing, just empty content or a blank white screen, there's a lot of things that could cause that. If you get a clear error message in your console saying, tried to get a property off our data response and got nothing, you know what the problem is. It came from the back end. So if you don't control the data, if the data is coming from a third-party API, not much you can do other than have really robust error handling. This is where having a strong contract, knowing what you expect from them, and then just bailing out if you don't get it. That's absolutely crucial, especially if you can't trust the API. And if you really can't trust it, maybe you want to set up an intermediary so that you can trust that intermediary and mirror it if the data goes down, something like that. With internal data, that's all you. If you don't trust it, you're not trusting yourself. You're not trusting your coworkers. Like if you can't trust the data that's being passed as an argument or as a prop in React, then that's a big problem. So then that's a code problem. You should be fixing that. Yeah. So if it's not trustworthy, then you need to validate it quickly, and you need to log any exceptions that happen so that you can find it faster. Some other internal data could be values from libraries. Maybe you're using Formic to handle libraries if you're doing, or to handle forms if you're writing React. Things like that. So, things that would generate data from within your application. Most of them will actually be extremely explicit about what contracts they enforce. So I have a link here. Axios, for example, very commonly used request library. It has an actual schema. It says, this is what you can rely on us to give you. So a lot of libraries will give you something to that effect, a very clearly defined contract of what they are actually going to give you. And really, if they don't give you a strong guarantee, then that's not really a great library. If they're flaky, if they're going to cause you problems, then maybe don't use that one. Maybe find another one. There's lots of libraries on NPM. So there's a lot of costs of just being safe. If you're going to use a chain of and-ands in order to suppress an error from popping up, that actually has significant performance implications. Each individual one, pretty much negligible, but if you've got 5 checks for every key, and every component is doing that, and every single time it renders, it's doing that check, that's a big performance hit. There are some benchmarks of React. So React actually has development and production mode explicitly for this reason. In development mode, prop types are checked, warnings are checked, all of that sort of thing. A lot of that affects bundle size, but one of the big things is that it will not run these conditional checks to see whether the data is the shape that you expect. And some benchmarks show that production mode is between 2 and 8 times faster than development mode. So if you're not optimizing out, if you're doing these checks and not optimizing them out in the code you ship, that can be a huge performance impact. And reading code that does these checks is much more cognitive overhead. Less so if you're using like lodash.get, something like that, that makes it a little bit more abstract, a little bit clearer to read. But every time you read it, it's going to slow you down a little bit. You're going to have to wrap your head around, especially if the formatting is inconsistent. If sometimes it's and, sometimes it's a ternary, sometimes it's lodash.get. It's a lot of context switching, a lot of figuring out what's going on. And there's also the additional problem of when you write more code downstream that is expecting data from other code that tries to just be safe, you don't know if you can trust that because it doesn't trust that data. So why would you? Unless you dig down into the source of the data, not the intermediary that you're getting it from, to find out whether or not those error cases will ever happen, then you just have to assume that they might. And that is either a lot of cognitive overhead of digging into your dependencies, or handling these error cases yourself, again. So how do we fix this problem? We really need to ask ourselves these questions when we're writing code. What kind of errors could happen? Under what circumstances? Like if we're making an API request, might document not be there? If not, we probably shouldn't provide a default value. We probably shouldn't even do that check, let alone provide a default value. Are you handling the errors that you can foresee? Obviously, if you're making an API request, sometimes it's going to fail. Sometimes people aren't going to have Wi-Fi. Wi-Fi is going to time out. The backend is going to not respond quickly enough. The backend is going to have a database problem. There's lots of failure cases. That's the most obvious one. .then, .catch. But there's a lot of other things that you should ask yourself when trying to find out what kind of errors might happen. And that's very dependent on what code you're actually writing. And when you're thinking about errors, are these the kind of errors that should only happen when you're writing new code, or might it happen in production? Back again to API requests. Obviously, sometimes those are going to happen in production, so you should handle it, absolutely. But if the only time an exception will be thrown is if invalid code is written, then you should probably just throw the exception, because that's going to help you as a developer figure out what code you wrote wrong. And if you provide a default value, can you actually use it, or are you just putting a log on your trailer? Is it just going to keep on trucking until at some point it breaks catastrophically, and now you have an error very far removed from when I actually introduced it? And these are really questions that you absolutely should be considering every time you write code. If you don't have time to ask yourself these questions, do you have time to handle the bugs that are going to pop up? Probably not. So sometimes organizations are going to push you to ignore it. Just push, release, ship code, ship features. But it's a very short-sighted stance. That is a condition where you absolutely should push back and say, no, we need to think this through. We need to handle this properly. So bringing up a specific code example of fixing these problems. So here we have a pretty simple React component, makes an API request in component mount, and renders a title. It uses both of those bad patterns that I hate from before. So what can we do to make this better? What are a couple changes? Catch, absolutely. Although actually, fun thing that I actually only just learned a couple days ago, instead of .catch, what we should really be doing here is passing a second argument to .then. It accepts both a success and failure handling, failure callback. And I didn't realize this until a couple days ago, but .catch is actually very similar in behavior to a try-catch block. So if anything in here throws an exception, it's going to go into your .catch block, that's not what I expected. I thought it was only going to be the network requests. So for example, if you're dispatching something to Redux and and you try and get a data key that doesn't exist, that's going to go into your .catch. And if you're just setting state with the error, it's going to make it harder to debug. So good suggestion. I only just learned that the other day, so I'm trying to spread some knowledge. Very good idea. One thing that I would say is we are doing this right here. We need to be aware of what the URL is, what the actual request library we're using is, what the shape of the data coming back from the request library is, all of that. If we had some sort of API abstraction where we could just say, I want to make this request, I want this data, then we could put all of this part of it somewhere else. Have something else maybe it's even responsible for validating that the response came back in the shape that we want. So that right here we just say, I want this data. And somewhere else we can put all the code that handles all those possible errors, surfaces the development errors that we want earlier. Another one that I would say would be to separate the fetching of data and the presentation logic of actually rendering it into DOM into separate components. That's commonly called the container and presentation pattern. Yeah, Dan Abramov really sort of popularized that. But so here's a possible improvement. We could have an API layer, get data and validate, something like that. Doesn't even need to validate. It's just now we are not tightly coupled to the actual request library we're using. This doesn't even know, all it knows is that it asked for data and I got some back. It doesn't know any of the mechanics about what's happening behind the scenes. Then we don't need to actually be aware of what the response coming back from our request is. We just get the data. All we get is the actual response from the API. Then this component would be responsible for handling errors. I usually like to do a little bit more explicit error handling, but there's only so many lines. I usually like to have in state a network status string enum, something like that, where it would be like idle, pending, complete, error. Something where I can explicitly say, oh no, what state we're in, so that we can handle it more explicitly. But that's another line up here, it's another line right here, it's another like 4 lines right there. Didn't fit. So in this case, just extremely basic error handling. If we have a document from state, then render the page. If we don't, it's probably still loading. Probably. And this actually gives us another nice abstraction point where we can add something really powerful for us as developers, prop types. This is sort of a stopgap. It's better to use static typing, because then this won't even compile if we don't give it what it expects. But prop types are nice. Instead of just could not read property of undefined, it tells us, no, it was this part. This thing is where it failed. It's all about finding what caused the error faster. Prop types are great for that. They're extremely easy to add to any existing React project. Highly recommended. And yeah, so now additionally, instead of starting from the document and then getting the page and then getting the heading and then getting the title, we've now sort of separated a little bit. This part is now getting our page off the document. So then this page component only cares about what the actual page is. So then we have an even shallower deep object. There's fewer points. There's some parts in here that might fail because bad data or something like that. But then other parts are handled within here. That's one way of making your objects more shallow, so that you don't have to do that kind of very deep object inspection. Like I said, prop types are great, but they're runtime. They can help you surface errors faster than you might find them otherwise. But static typing will do that even faster. It won't even compile. You don't have to test it. Does this page render? Does this page render? Does this page render? Does this modal render correctly? If it doesn't, it won't even build. And it'll tell you exactly what problem is causing it to not build. That requires a lot more deliberation, and it can be a significant slowdown. But a lot of the time, especially for more like hot code paths, the kind of things that are going to be changing frequently or are very complex, types can be a huge benefit, especially for refactoring and things like that. And actually, to give one specific example of how types can be insanely powerful, I talked to one developer. This is Jared Palmer, who some people might know. He's made some very incredible open source libraries. He's using GraphQL. GraphQL enforces that you use a schema in order to describe the shape of your data. And he's generating TypeScript type definitions from his GraphQL schema, which means that he can statically verify that his front end and back end are compatible, which blew my mind. So anyway, types can be extremely powerful. But what about data that varies? Sometimes there are legitimately cases where we might get this data, or we might get that, or we might get something else. That's fine. That's going to happen. But you should do it as close to the source of the data as possible. You should validate that it's one of the expected cases and only one of those expected cases. If it's not, surface an error as soon as possible. You should be logging errors. You should be using something like Rollbar or Splunk or anything like that, something that catches all unhandled errors and just logs them so you can see what's going on. And so know what to expect for each of the possible responses and just handle them very explicitly. The more explicit you are in handling data, the faster errors pop up and the less time you waste hunting down obscure bugs. So all this is really to say, think about your failure modes. I lived with a couple of automotive engineers for a couple of years, and one of the things that they had to do that they complained about a lot, but it was FMEA, failure mode effect analysis. This is a critical part of engineering for safety critical applications. It's understanding what happens in failure cases. They were automotive engineers, so they had to understand, if a car hits another car, what happens? What happens to the frame? What happens to the engine? What happens to the fuel tank? All of those different parts. We as software engineers, obviously, if there's an error, we're not going to kill anyone. So maybe we don't need the organization to rigorously enforce that we do thorough FMEA before every deployment. But at least thinking about that, thinking about what errors could happen, what behaviors occur when they do, can help us write more robust code. And just to give a couple of examples, I have some snippets from, this is aerospace failure mode effect analysis. Obviously, they have to do extraordinary amounts of failures. These are full scale, like that's a real 777 that they just bent the wings until it snapped. And you can actually see how many people are there watching it right at the front. So like, this is the kind of stuff you have to do if you're in aerospace. If you're in absolutely safety critical, hundreds of people die if something goes wrong. This is the kind of tests you have to run. We're not there, but but you think about it. Think about it a little bit.
Software, if you have like aviation software, that could.
Oh yeah, absolutely. And I'm sure that the avionics equipment has a similar, maybe not as dramatic. It's not a flaming out engine, but they do a similar kind of FMEA. So when you do something just to be safe, take that as a hint that you're missing something. You don't have you don't know everything that you need to. There's an unknown. Ignoring those sorts of hints can cause small problems to accumulate into large problems. So know what errors you want to see when you're making changes, know how to guard against the errors that you don't want to occur in production, and learn how to trust your code. So for some other reading, this talk was based off a blog post that I wrote. It's on Medium. I'll put these slides up somewhere. I'll put them in the meetup group so you can find them. And this is not original thinking. I'm not the first person to talk about this. There's a classic ThoughtWorks post article called Fail Fast that is basically the same thing. Error quickly, surface errors fast, and write more robust code. Questions?
So it's interesting.
Yeah,
Say, I would bet that the two examples that you gave at the beginning of the talk of passing the empty object in
right.
and handing all the things together, I would wager that code was probably not originally written that way, and that sometime in the night someone had to make a fix,
right.
and they passed that empty object and find everyone rolled on.
I would agree with you.
So this comes to the tech debt.
Yeah.
So this is really a form of tech debt, and I'm really curious as to how you guys approach tech debt, and are you explicit about going back and cleaning this up? It's one thing not to write it, but how do you clean it up?
Right. Very good question. Excellent question. Really, that means if an error is getting to that point in the view layer where it's actually causing some sort of exception to make the page not render, then that means that it should be handled more quickly, really. Specifically about those examples, those ones were actually, I would have agreed with you 4 months ago before I really started working with them. But I've now done code review and had to, no, don't do this. Stop it. Yeah, it's really, I think the solution to the tech debt caused there is to handle errors more quickly, log them more effectively, and more rigorously enforce the contracts you have with the backend.
Would you clean that up? I mean, at some point.
Oh,
get people not to write it.
I would. I would clean it up. There's not always time allocated for that, but anytime I see it, I try to, if nothing else, centralize that validation so that it's not scattered.
Great code, enjoyed. I worked for a company, an open source company that require 100% unit test coverage. And I just wonder how and when, if you think that it's always good practice, or if sometimes it's just better to just give more flexibility, or when and based on what you would choose.
Sure,
the test coverage.
I am violently opposed to 100% unit test coverage. I believe that, I think the optimal value is somewhere 70-ish%. Depends on the code, depends on the module being tested. At a certain point, you end up writing just absolute monstrous spaghetti code in order to test it, in order to hit that 100% coverage. And your tests exist in order to help you trust your code more, in order to help you iterate more quickly. And once they stop doing that, once it becomes just a metric, you have to get 100%, then they're not helping you, they're slowing you down. And if something isn't helping you, stop doing it, in my opinion.
You mentioned a library friend of yours made that connects prop types with GraphQL
Right.
prop types. Did you mention the name? I mean, I missed it.
Not a library that I'm aware of. I think it was more just a tool that they wrote in order to generate it. This was something that he talked about while I interviewed for him with a job that I didn't get. So I think it's not something that's really ready for prime time. Not something open sourced. Regrettably, that would be incredible.
Have you ever worked in a team where the mentality is just like get it working, push it, and then maybe a year later you just have all this code that's built around like this thing that errors, but you have all these like really hacky like safety nets around it. Like, how do you deal with that? And like, did you ever like try to change the mentality of the people you work with, or do you want to push back on that? Or?
I have. I will leave them unnamed.
Okay.
Yeah, that is a big problem, especially if the habits are deeply ingrained in the other people. Like that's really the struggle. It's not that hard to fix this code where you find it. You know, wherever the data is being fetched, throw an error if it doesn't work, if you don't get what you expect. And then it's just a matter of deleting all the checks that you then know will never evaluate to false. So fixing it is actually not that difficult. You know, I mostly just do it as I go. Not really like a big single overhaul refactoring. As for changing mentalities, I'll let you know if I figure that out. I think doing things like lunch and learns, code reviews, all sorts of, anything you can do to communicate ideas between members on the team. I think that's the only way to address it. I don't think there's any sort of silver bullet. Hypnosis, yeah. I'll have to give that a shot.
Oh, sorry. But yeah.
Nope.
Actually, I wonder, I totally agree with the idea of asking all these questions to yourself as a developer, but would you suggest to actually have more a structured way to do it, that is more like team-wise, that you write down black and white and you dedicate a bit of time just to thinking what can go wrong, or it's more an appeal to, as a software developer, it's a good sense, good practice for yourself?
That's a good question. I have not done any sort of more structured approach to it. My password is definitely not space. Don't tell anyone. No, I am not. I'm not really focused enough, and I'm a little bit too ADHD to really have a more focused approach, like deliberate, step-by-step, documented approach to it. It's mostly just something that I try to keep in mind as I develop. I think it would be valuable to have some sort of review process around it, but I don't have anything.
I'm super curious. So you discussed, the view layer versus the API layer,
Right?
And a lot of these error handling, that n is basically because you got data back, from your. You decided to make a network request, right? In there in your component.
Right.
So abstracting that out in React world, where would you say like the API layer begins? Where does the view layer end, and where is the best point to start your API layer?
It's a good question. I think it depends a lot on what other tools you're using in addition to React. Because React is definitely very much just the view part of the application. If you're only using React, then just doing like container components, something where its only job is to make a request and validate that the data is what you expected, I think that's acceptable. I've done that a lot on small projects. Once you have something like Redux or MobX, that is more where you should be doing this sort of data validation and expectation management. Is your follow-up?
Yeah, follow there. So, and then, you always come into the case, with what you're describing is that a lot of that could be solved by flattening your data, right? You have attribute types, and these attributes are all nested, and you decide to hash all of them in the back end and throw them all in the flat structure, right? So, is that a better approach? Is that,
to an extent. I mean, so that sort of gets into the topic of like data normalization. I would say that normalizing your data and making it shallower and really only dealing with the data that you want to handle with that particular block of code. So rather than passing in everything into this component and then peeling off little bits that you want, split it up. Have a container that chunks up your entire data set into little bits that it passes into this component and that component. It passes these two into there. So then each of those small, more limited in scope components only get the data that they need. And they further chunk that up into smaller bits of data that pass it into smaller, more focused components. And it's React is a tree structure, and I think that that's a good way of thinking about your data. If you look at the whole thing, it's a big old blob. But if you look at each individual part, it's more simple, it's easier to reason about, and really you should be able to get it to that state so that you can more easily reason about where it should go. Yeah.
You were talking about static typing, which I also really love. Are you using TypeScript on your projects, or are you using a different static typing approach?
I am not using any static typing at my job professionally right now. I haven't actually worked with any static typing at a job. I have used it on personal projects and just absolutely loved how productive it made me when I was making changes. It really gave me just a tremendous amount of confidence to say like, yep, this works. I can ship this and I know that there are no bugs. But no, we're not using anything. I also saw, I just heard about this the other day, T-comb. It's not static typing, but it's kind of like prop types for anything. It's kind of neat. It's basically just like assertions. You can say at a function, this thing is a number, this thing is a string. And then it'll be a runtime exception, but it's like prop types, but more aggressive. Instead of just warning, it'll actually throw an exception. So that was an interesting middle ground without changing your build process. Yeah. Okay, cool. Anyone else? Good?